All right, welcome to lecture 30 on dictionaries in Python, the first part of this series of lectures on dictionaries. Now, if you have prior experience with data structures in computer science, you must have come across hashing and hash tables. So, you can think of dictionaries as an implementation of the theoretical concepts that you have learned in hashing. Loosely speaking, whatever we have learned in hashing can be thought of as a dictionary. So, your hash tables are equivalent to a dictionary. So, giving you some context, if you have a computer science background and if you do not have any prior knowledge on data structures, that is also equally fine. You can think of dictionaries as mappings. So, dictionaries are mappings from one set to another. Now, when you're talking about mappings from one set to another, you're essentially referring to mappings from keys to values. Mappings are essentially what? Mappings are essentially objects. Now, in dictionaries, Python dictionaries, what we do is we map keys to their corresponding values. And here, mappings or dictionaries store these objects, store these values by the position of the keys. So mappings will not maintain any predefined order. That is a drawback, you could say. In dictionaries, we cannot perform traditional indexing that we have seen so far. We have seen indexing in tuples, we have seen indexing in lists, indexing in strings. However, dictionaries, although dictionaries are considered to be linear structures, or maybe that could be an overstatement. Even if you leave out this portion on linear structures, dictionaries, although they are considered as collections of values, these values cannot be indexed in the traditional form. So you cannot use positive indexing or negative indexing like you have seen earlier. But what you can do is you can use the keys of a dictionary in order to access the values. And there is a direct relationship, there is a direct mapping, there is a direct association between the keys and the values. And mind you, dictionaries, they are not sequences, which is why you cannot do traditional indexing on them. And dictionaries, however, are mutable. So just like we have seen in case of lists, which can grow and shrink accordingly as required, we can also have dictionaries which are capable of growing, and even dictionaries which are capable of shrinking. And dictionaries, they are very flexible, just like we have seen in case of lists. And these dictionaries, they are very suitable when we are trying to create a tabular like data structure. We will get into a particular library of Python called pandas, and pandas works essentially on a data structure called data frame, and dictionaries are very much similar to these data frames. And you can think of data frame as a tabular structure storing all our values in terms of rows and columns, and dictionaries have a direct relationship with these data frames. So we can take a dictionary and we can convert it directly to a data frame. That is possible, but more on that later. Let's focus solely on the dictionary portion in today's video. So we'll start by creating a dictionary called D1, and this dictionary D1, it has three keys. The first key is the role, the second key is the name, and third key is the age. Now every key has a corresponding value. So the key role has a value 23, the key name has a value Ron, and the key age has a value 22. Now, when we create this, as we get back no error message, that means this creation has been successful. And if we print it out, this is what it looks like. Dictionaries are denoted by the pair of braces around your key value pairs. So what you see here, if I could highlight this portion, this is an example of a key value pair. where the key is roll and the value is 23. Another example of key value pair would be this. Key is name, value is Ron. Another example of key value pair would be age 22, where age is the key and 22 is the value. This is the point that I've been emphasizing on right from the outset, that dictionaries are mappings, and mappings of what? Mappings of keys to values, where every key is separated from the corresponding value using the colon. So here age is the key which is separated from the value 22 with the help of colon. Let's go ahead and create another dictionary called D2 and let's print it out. So the moment we print it out, now we see that dictionary D2 is slightly different than dictionary D1 in the sense that previously in dictionary D1 we had single valued literals, right? So roll had an integer value 23 attached to it. So roll is the key and it has the corresponding value 23 attached to it. There is the key name which has the value which is a string, another single valued literal called wrong. And again, age, another key, the third key, has another single valued literal called 22. Here in dictionary D2, we are creating a dictionary where the values are no longer single items, the values are composite items, and here the composite items are created using a list. So roll is now a collection of three values present in the form of a list. Name again is a collection of three strings present in the form of a list, and the same goes for age. So remember, your values can be single items like we saw in case of dictionary D1. They can be single valued items or they could be composite valued items as we see in the case of dictionary D2. This flexibility is offered through dictionaries. Although dictionaries, if you could go back, we mentioned this point, although dictionaries are not sequences, however, they are a very flexible data collection, or you can think of dictionaries as a very flexible data structure which is able to not only have single valued keys but it could also have composite keys. That means a key which is made up of multiple values. You could also have had a list. Instead of a list, you could have also had a tuple. So this age could have been a tuple, but mind you, then what would have been the difference? Then you could not change the value, right? If you want a composite valued if you want a composite value for a particular key and you don't want that value to change, then instead of going with a list you would go with a tuple. We have seen in the earlier lecture that a tuple is a collection of items. Once again, it's a collection of items, but a tuple is immutable. That means once a tuple is created, whether it be an empty tuple or a non-empty tuple, once a tuple is created, it cannot be changed. Likewise, if we are looking to create a value for a key which we do not want it to change, then we would go for a tuple as the composite data structure instead of a list like we have done here. So if we do not want the names to change, if I do not want these names to change, then I'll, instead of using a list, I'll be using a tuple. So you could probably see this. As you can see, I've now created a tuple. Let me remove the square brackets and I'll call this D3. If I call this D3 and now if I execute this, you see it goes through. If I print D3, now you see my name is a collection of tuples. I mean, it's not a collection of tuples, but name is a key where the value is a tuple. The value is a tuple consisting of three elements. So this is also possible. It's not that you will always have a composite valued key as a list. You will not always have a composite valued key as a list. A composite valued key can also be a tuple, provided you are not looking to change that composite valued key. Right? If you're not looking to change that composite value that you're creating, then you can go for a tuple, and that's again advised. But if you're looking to change it, then go for a list. Now, coming to the next question that we are looking to answer, how can we fetch values from a dictionary? As I said, you do not have the concept of indexing, neither positive indexing nor negative indexing. If you have to get values from a dictionary, you will have to use the keys in order to get back the values. I want to find the I want to find the value for the key name in dictionary D2. So if I execute this, I see that the name is a list of three values. Likewise, I want to find the value for the key role in dictionary D1. Then what do? I enclose my key, which is role, within square brackets, and I mention the name of the dictionary prior to it. And if I execute this, I get back 23. And if you could go up, if you're not convinced, then you would find that this was our dictionary D1 and the role key had a value 23. That means the output that we are getting here, 23, is absolutely correct. The next question that we are trying to answer is how can we change existing values in a dictionary? Now, mind you, this is possible if the value is mutable. If you're using an immutable data structure like a tuple for a value of a key, then you cannot change that value. So if I want to print out the name, the value for the key name in dictionary D1, it's Ron. And if I want to change this to Ronaldo, all I need to do is I need to access that key using the dictionary name and just assign it the new value. If I do that and if I print out the name once again, I get back Ronaldo. Straightforward. So remember, in dictionary we access values using their corresponding keys. Now, can we build up from an empty dictionary? The answer is yes. We wouldn't be able to do this had it been a tuple. We had seen this in the earlier lecture that if it is a tuple, you'll not be able to change it, right? So if you have created an empty tuple, it's as good as useless because you'll not be able to append items to it. However, in dictionaries, we have this concept whereby we can add more values for an existing key. So let's create this dictionary D3 and let me try to explain this code. I have three lists as you can see: role, name, and age. What we are trying to do is let me reduce this range, let's say 3, so that it takes less amount of time to execute. So what I'll do is I'll go over this loop 3 times, and every time the loop iterates I'll be accepting 3 values from the user: the roll number, the name, and the age, and I'll be appending it to the corresponding list. So what's happening is the moment I accept roll number from the user, I'll append it to the list role which has been defined earlier, the empty list role. The moment I get the name from the user, I'll be appending it to my existing list name. The moment I get the age, I'll be appending it to my existing list age. And once I'm done, so how many inputs will I be accepting from the user? 3 inputs, right? 3 inputs, where every input will have the role, the name, and the age of the concerned person. And once I get these values, what I'm doing is I'm simply building up the dictionary. So how do you build it up? You write the name of the dictionary, you write the name of the key, and you assign it with the value of the list. So what is the list that I want? The role list. I take the dictionary, I take the key which is name, and I assign it the value name because I want the list of names to be attached to the key name. I am taking the key age. So here I am defining the keys, mind you. The moment you use the key with a dictionary for the first time, you're actually creating that key. And for the key age, I am assigning it the value age, which is the list of ages, the list of age values that I've obtained using the for loop. Now, if we run this, so I'll have to enter the inputs thrice. That means I'll have to enter roll number, age, name once again, roll number, name, age, second time, roll number, name, age, third time. So let me do that. Let's say roll number is 6, name is Pritam, age is let's say 31. Roll number is let's say 73, name is Nadeem, age is 30, and let's say roll number is 2, name is Shweta, and age is 25. Now once this dictionary is done, let's print it out. There you have it. all the inputs that we have entered. You could pause the video perhaps and verify this. So all the values that we entered here, they have been nicely packed to create a dictionary called D3. Now, if we move ahead and yeah, so as I was saying that you could verify this, perhaps pause the video and have a look that these are the values. These are the values that have been correctly packed into our dictionary D3. Now, there's another way we can pack these values, and that is using the zip. Now, what zip will do is, pay attention here, you don't want to miss this. So, what zip does is, it takes, so if you see this zip, if I could probably break it up across multiple lines, then I think it will be clear to you. Yeah, let me just bring this down again. Yeah, now I think it will be clear. Yeah. Now let me just get this slightly to the left. Yeah. So the indentation helps a lot in understanding what's going on. That's why I'm fixing this for you. Yeah. Now if I could just, yeah, I think this is fine. Now you'll understand. So what zip is doing is, it is taking, so forget about this dict part first. You ignore this for now. Focus on this portion. Focus on this portion and see what's happening. So zip, what it's doing is, it's taking this list, role, name, age, and it is taking a list of lists. Can you see? There's this outer list here, and within this outer list there are three lists. So there's this list, and there's another list. Now here, what's happening is, role is being zipped or is being attached with the list, the first list that I've highlighted here. Then the name, which is the second value in my list, in my first list. See, zip is taking this first list. This is the first list which has been passed to zip. Now, in this first list, the second item is name. This is zipped or this is attached with the second list that we see here, second list of names. And the third string, which is age, is zipped with the third inner list, which is this. Now, once this zipping is done, once this attachment is done, this corresponding attachment is done, if we convert it, if we pass it, if we pass the entire thing, so this is our entire zip function, if we pass this to the dict, so here dict refers to dictionary. That means if we typecast it to dictionary, what we'll get is a proper dictionary. So if I run this, there you have it. So this is a dictionary which we have obtained with some shorter lines of code, right? If you would have done this using this for structure that I've shown just now, we could have done this using this for loop kind of structure. But if you know the zip function, which I believe you know now, you can combine your lists in such a way that one list behaves as the keys. So this particular list is behaving as my list of keys, whereas this inner list, or you see, this is another list. So there are two lists that I'm passing to the zip function, and this second list, which consists of three more lists, right? Again, I'll repeat this. See, my zip function is accepting the first list, which is providing the keys for the dictionary, and the zip function is taking another list. This is the second list. Now this second list, which is given to the zip function, this consists of three inner lists: the first inner list, the second inner list, and the third inner list. Now the first inner list gets attached to the first item in the first list. The second inner list gets attached, the second inner list, which I have now highlighted, gets attached with the second item in the first list. And this third inner list gets attached, this third inner list gets attached with the third item in the first list. In this way, we are able to create a dictionary with the help of the zip function. Now the next question that arises is, can we nest Python dictionaries? That means, can we have a dictionary within a dictionary? The answer is yes. So if I look at this. So this is my dictionary. This is my actual dictionary, the original dictionary that I'm trying to build. Now this dictionary has a key called name, and the value is a dictionary. Can you see? The value of this key is a dictionary. And this value consists of, you can see, key value pairs. So this value, which is a dictionary, the part that I'm highlighting now, this is a dictionary. Now this dictionary consists of, again, key value pairs. So the first key is first name, consists of three values enclosed in a list. There's a second key in this inner dictionary, which consists again of three values enclosed in a list. And there is another key called job. Now this is part of the outer list, mind you. The job consists of a list of job designations, and there is the last key, age, which consists of a list of age values. Now if we run this and if we print out, so let's say I want to access all the first names present in my dictionary. So how do I do that? I would require two levels of indexing by keys. So the first indexing would be, so what do I need? I need all the first names. Now first name is dependent on this key name. That's why we first mention the name of the dictionary, my.org. We mention the name of the dictionary, my.org. Then we mention the outer key, which is name. And within name, there is another key called first name. So we mention that within square brackets. And if we do that, we get back all the first name values. Similarly, how do we get the last name values? Again, we mention the name of the dictionary. We mention the outer key, which is name. And we mention the inner key, which is last name. So if I say my.org of name, it refers to this entire dictionary, right? If I say my.org of name, it refers to this entire inner dictionary. Now in this inner dictionary, I'm looking for the last name. So what do? I add another level of key, which is last name within square brackets, and I get back the value. So now if we execute this, we get back three last name values. Now, what if we want to print the full name of the last employee? So, what do? Here, what are we getting? We are getting first names in the form of lists, last names in the form of lists. And we know for lists, negative indexing is applicable. We have seen how to get the first name, how to get the last name. So, that part remains the same, the part that I've highlighted. Now, here, the portion that I've highlighted is same as this particular print statement. And this particular print statement gave us back the list of first names. Now from this list of first names, I'm looking for the last name. I mean the last value. So from this list of first names, if I'm looking for the last value, I can simply do a -1 indexing, which we have done here. Similarly, for the last name also, we are accessing the last name, the list of last names, and we want the last value. So we are doing -1. And the moment we print this out, we see that Tim Cahill is the full name of the concerned employee. Next, let's say we want the second listed job. That means we want clerk. So what do? All we have to do is we have to mention the name of the dictionary, which is my.org. We have to mention the first key. So within this dictionary, the job descriptions are present under the key job. Again, if you have confusion, I could go up and show you that this key job has the list of job descriptions. So if I do my.org of job, what do I get back? I get back this entire list of job descriptions. Now from this entire list, I don't want all the values. I want only the second listed job. So if I do an index of 1 on the list, what do I get back? I get back clerk, which I was looking for. Now the question arises, can we append more items to an existing list, which is the value for a key? For example, can we append another job to our existing list of jobs? So here, if I could create another cell and show you what are the existing jobs and how do we get it, all we have to do is remove this indexing. These are the three jobs that we have so far. Now we are looking to append one more job to this existing list. So what can we do? Now because this is a list, all functions that we have learned for lists are applicable. And which function will we be applying here? we'll be applying the append function, because the append function helps us to append new items at the end of the list. And that is exactly what we have done here. So if you see, we are first mentioning the name of the dictionary, which is my.org. We are accessing the particular key, which is job. When we do that, we get back this list of jobs. As you see, I've done here, I've highlighted. And to that, if we apply the append function, we get back the value that we were looking for. What do we get back? We get back an appended list. So if I print my entire dictionary, I find that under job, now I have banker appended at the end. So that is how we can append items to a value for a key, provided that value is a composite value and it is a mutable data structure. So we know lists are mutable, which is why we could have called the append function like the way we have, and we have managed to make the list grow. Now, how can a dictionary grow? Very simple. So if you remember, we had created a dictionary called D1, which contains three keys and their corresponding values. Now, if we want to create another key value pair, all we have to do is mention the name of the dictionary, mention the name of the new key, which is DOB in this case, and mention the value of the key. So if we do that, and if we print out D1, we see that a new key value pair has been appended. It's as simple as that. But mind you, dictionaries are not ordered. That means, although we are getting back the values in the same order in which they were created. So when I displayed D1 before appending DOB, shouldn't use the word append. I could say before creating another key called DOB, we had the dictionary in this form. We had the dictionary in this given form that I've highlighted. Now, even after appending or even after creating a new key value pair, again, I'm using the word appending. It should not be appending. Appending is a term that is used exclusively for those data structures where we can append values directly at the end. So here we cannot append as such, but we can create new key value pairs. Now, when we are creating this new key value pair, DOB followed by the corresponding date of birth, we find that the order in which the dictionary is being maintained, that is preserved. So previously we had role followed by name followed by age, and at the end we have DOB. But there is no guarantee, mind you. This order could well have been scrambled. That means DOB could have been somewhere here in place of name could have moved up in place of role, age could have taken the place of DOB, whereas role could have taken the place of age. That could have very much been possible, because with dictionaries the order is not guaranteed. Please keep this in mind, and don't panic if you don't see the output in that order. That is how Python treats dictionaries. It does not preserve its order. If you want to preserve its order, you can sort the keys and then go about creating or accessing your dictionary, but that is a topic that we'll reserve for the second part of our lecture on dictionary. For now, just keep in mind the order in a dictionary is not guaranteed. Now, the next question that we would be answering is, how can we be sure whether a key exists or not? That means if I do D1 of wait, I find that I get an error message. Why? Because if you go back, if you recollect and print D1, you get back this dictionary. Now, observe carefully. Does the dictionary D1 contain any key called wait? It does not, which is why we get back a key error when we try to access the wait key for dictionary D1. Now, this is something that you would want to avoid. Now, for very large dictionaries, it's very difficult to know whether a key is present or not. And if you want to check whether a key is present or not, you can use the in keyword. So you could take the key, which is wait, and you could do in, and you could write the name of the dictionary. So if you do wait in D1, and if you get back false, that means the key wait does not exist in dictionary D1. Now this is one way of doing it. Of course, this works. There could be a better way, a more elegant way, a more elaborate way of doing it. So you could perhaps assign temp, a variable, with the value of the key that you're looking to check, And if you find, so if you could use this not in, just like you have the in keyword to check whether the value is present or not, you also have the not in keyword. That means if temp not in D1, what does this mean? This means that temp, which contains DOB, if DOB is not present as a key in dictionary D1, then print this statement missing key. I repeat this again. If temp, which is equal to DOB, is not present in my dictionary D1 as a key, then print missing key. Otherwise, print key found. Now, if we print this, we get back key found. So this is another way of doing it. And there's a third way as well. In fact, there are four ways that I'm showing you. The third way is using the get method. Now here, get method is a very powerful method which is used a lot in dictionary programming. What you do is, to the get method, you pass a key which you're looking to investigate, and you pass a default value. That means if this key which you have passed as the first argument, DOB in this case, if it is not present in dictionary D1, if DOB is not present in dictionary D1 as a key, then it will return this default value 0. However, if DOB is present in dictionary D1 as a key, it will return the value of DOB. So if we execute this, you remember that D1 contains the key DOB. That's why we get back the value for the key DOB. However, if we try to do it with weight, what will happen is we'll get back 0, which is the default value. That means weight is not present as a key in D1. That is why we get back 0. Now, there's another way of doing this, which is using the if else in a single line. So if we do D1 of weight, and if you look at this if condition, so the execution is like this. You check if weight in D1. So if weight is present as a key in dictionary D1, then you return the value. You do D1 of weight, you return the value. And if it is not present, you go to the else part and you print 0. So if we do this, here we get 0 because weight is not present in my dictionary D1 as a key. Now what about DOB? Same thing, DOB is present. So what will you get back? You will get back the corresponding value. Again, the execution proceeds in the same way. If DOB is present in D1 as a key, which is yes, then return the value in dictionary D1 for DOB. Return the value in dictionary D1 for DOB. And what is that? That is February 5th, 1985, which is exactly what was there. Again, if you want to verify this, you could just print D1 and there you have it. DOB contains the value Feb 5, 1985. Right? That brings an end to our first part on dictionaries in Python. If you found this video useful, do give it a thumbs up, do hit the like button and share this video with your friends. And please do subscribe to the channel. It will help me to record more such videos, and it will help you learn a lot, and it will also help me learn a lot by teaching you. So thank you for this one, and I'll see you again in the next video. Bye bye.